Hi guys, so it is Friday, so congratulations, you've made it to the end of your second week of distance learning. Today you're going to see that we have problem set 29. You have 3 geometry problems, number 2, 27, and number 30, which you do not have to do, lucky you. We're going to be discussing negative exponents and zero exponents. Okay, I've written a couple of rules on the board for you, so it would probably be a really good idea for you to also pay attention, write them down somewhere. They are written in your book for you already. I kind of am doing them backwards. The first one that I have written on the board right here is actually on page 122, and the second one is on page 121. But I want to cover this one first because this is the one you've already been learning and are familiar with. As a rule for the product exponent rule, we know that when bases are the same, we simply can add the exponents and come up with x equals m plus n. So if I had, for example, 2 squared times 2 to the 4th, I would have 2 to the 8th as an answer. Okay? Why that's important is because now we're going to start learning what we do when we have a negative exponent. Okay, sometimes we're going to end up with a negative exponent, and that's okay. So suppose you have a 1 over x to the n, and you want to, it actually starts like this, so 1 over x to the n, and you want to bring the denominator to the top so that you can clear the denominator and not have a fraction. So basically you would just put the base and you would put the variable, but instead of having the sign positive like it is here, you would make it negative. If that was a negative already, then you would make this positive. So essentially, whatever sign this is, you make it the opposite sign when you write it in the numerator. So we're going to cover a few examples like that. So let's take a look at example 29.1 says, okay, so it says 3 to the negative 2 power. So the way that you would simplify this is you would take the 3, actually you would take this expression and you would write it as the reciprocal. So in order to get the reciprocal, I'm going to put a 1 here. Now I'm going to flip it, put the 1 on top, put the 3 on the bottom, but I'm going to make the 2 positive, and I have 1 over 3 squared, so 1 over 9. Now the point of this is that we don't want to have negative exponents. Generally speaking, when you have a negative exponent, that is not a simplified equation. So what we're doing is we're learning that we can take the fraction and flip it, and when we flip it, it changes the sign of the exponent. So please be careful here. One more time, that was a negative 2. When I put it over 1, I flipped it and made it 1 over 3 squared. And I get 1 over 9 as a solution. Okay? Let's look at another example. The next one says 1 over 3 to the negative 3rd power. Okay, so this is example 2. It says 1 over 3 to the negative 3rd power. Again, I don't want to leave it with a negative exponent, so I'm going to simplify it by writing its reciprocal. Now, a reciprocal is just you flip the fraction. So the 1 would go in the denominator, the 3 to the 3rd would go on top, and notice the negative now becomes a positive, and then you simplify 3 to the 3rd equals 27. We wouldn't leave the 1 because then that's not simplified. Okay? Let's look at the next one. It says x to the 4th, so this is example 4, x to the 4th m squared x to the negative 2nd power and m to the negative 5 power. And I'm actually going to move these out of the way. Okay? And this is now going to say x to the 4th m squared x negative 2 m to the negative 5. The directions say simplify. Okay, so simplify means I want to solve this without negatives. Now, there are a couple ways you could approach this. I'm going to try to make it as easy as possible on you. Let's go back to our rule. Our rule states that, the product exponent rule states that if the bases are the same, we can add the exponents. So the first thing you want to do is add the exponents. So just like we've been learning, we're going to put the variables that are identical next to each other. We're not going to do the reciprocal or anything else just yet. We're going to put them next to each other. So we're going to regroup using our associative property or cumulative property, and we're going to write x to the fourth, x to the negative 2, m squared, and m negative 5. Please take your time and transpose it correctly, and please put them in order, because if you do not, and actually let's do it the way we've been learning. I should have put them alphabetically, so I'm going to say m squared, m to the negative 5, x to the fourth, x negative 2. So I put them alphabetically, and I put the positives first, okay? Now I'm going to follow my rule. The bases are the same, so I'm going to say 2 minus 5 equals m to the negative third. And then over here I have x. I'm going to take that out because that kind of looks odd there. I'm going to say x to the second power. So I have m to the negative 3x squared. Now, at this point, if we look at the answer in the book, we have x to the third, m to the negative 3. Notice that they left it as a negative 3. That's okay at this point in the lesson. You do not have to make the negative 3 positive like it did over here, because it didn't say leave the answers as positive. If it tells you to make sure your exponents are only positive, then you would have to take one step further like this. You would say m negative 3, x squared, and you would have to make this positive by putting it in the denominator. So you would say this is already positive, you would leave it alone. This is not, so you would put it in the bottom, you would put the 3 there, but you would change it to a positive m. So it would look like this. It would say m to the third, and that would be the answer. But again, this step is not necessary unless the book specifically says to leave your answer with only positive exponents. If it does not say that, then it's okay to leave it this way. You will not get it wrong. Okay? All right. Let's see. I am going to pause the video and give you a part 2 so we can go over a couple of other examples.